In this talk, we describe AI explainability practices that arise in real world AI based products, specifically within NLP applications. I'm Shipi Dhanorkar, and I'm excited to be presenting our work on behalf of all my co authors, Christine Wolf, Qian, Anbang, Lucian Popa, and Yunyao Li. Our talk is titled Who Needs to Know What When? Broadening the explainable AI design space by looking at explanations across the AI lifecycle. Our daily lives are filled by encounters with AI infused products. As contemporary AI products become sophisticated, so do their complexities. One problem that confronts us is the comprehension of the inner workings of the model and an understanding why a model did what it did. The growing realization of the substantial roles AI models play in our lives brings explainability of AI models to center stage. Our main goal was to understand how various actors in industrial AI projects engage with explainability, the material qualities explanations take, and the tensions that arise as situated actions unfold. We build our study on a range of research that describe algorithmic advancements for building explainable models and the human centered perspective on explainable AI that explores these advances in relation to their human and societal implications. Our empirical study focused on AI projects related to text data, a key application area within industrial AI projects. While language has an underlying grammatical structure, in use it is rich, expressive, and messy. These complexities make computational modeling of language challenging. Our contributions in this project are threefold. First, we build an in depth empirical understanding of explainability practice in real world projects. This generative research offers a rich description of the collaborative sense making surrounding AI models. Second, we spotlight the AI lifecycle as a lens to characterize explanations as situated, describing the actors that interface with the AI model at the different locations, which we call AI touchpoints. Third, in taking this complementary view, we expand the ambit of explanations, moving beyond binary ways of thinking whether an AI model is explainable or not. To capture a variety of experiences and perspectives across the text analytics projects, we conducted an interview study with 30 participants. Our informants represented a range of roles across a variety of industrial AI projects, including technical AI research and development roles like data scientists and AI researchers, those who are in strategic development, as well as those focused on user experience design and InfoVis research. They also represent a range of AI expertise, some who are relative newcomers to the world of AI on the one hand, and several years of experience or grad level expertise in AI on the other. One product manager talked of the brutal steep learning curve to get himself acquainted with AI. Participants were working on a variety of domains, for example, document analysis of legal contracts, identifying key opinion leaders in the medical domain, text generation for applications in HR, and many more. Our semi structured interview approach allowed informants to contribute to an interactive exploration of our inquiry areas, namely who touches the model, what are their informational needs, and when do explanations get warranted. During the interviews, many informants also showed us artifacts that they developed to explain models, like slide decks, scientific papers, dashboards, and InfoVis applications. We iteratively analyzed the interview transcripts and notes, beginning with open coding to develop categories and themes. Early in the AI pipeline, during the model conceptualization and model building phase, model trainers use explanations to peek inside the model, get a sense of why a model is predicting what it is, and what linguistic features it might have learned. Similarly, other details like hyperparameter tuning could be informed by explanations and also be used to debug or brainstorm different algorithmic designs. In the model validation stage, an important part of discussions with clients revolves around data, and this was a dominant theme throughout our informants accounts. As novel sources of data are fed into the model for an existing business process, newer explanatory articulation work needs to get done. During the initial AI model development phase, clients and their legal teams provide high-level privacy requirements specific to their domain. These are fed into data pre-processing steps so as to develop appropriate masks and filters for personal data. During the proof of concept stage, discussion about this data preparation and mapping between privacy requirements to the data masks and filters comes to the forefront. Here, clients raise questions pertinent to regulatory issues with respect to the AI model. Explanations are geared to assure appropriate legal compliance. Drawing from a client conversation, one product manager mentioned, quote, "How do we know the model is safe to use? Users will ask questions about regulatory or compliance-related factors. Does the model identify this particular part of the GDPR law?" When the model is in production, an HCI researcher aptly characterized expectation mismatch that occurs between the model's prediction and the user's anticipated prediction that elevates the need for explanations. Another technical strategist indicated that explanations help in distinguishing outputs manifested through model mistakes versus decision disagreements. In discussions with our informants, we also saw explanations as being closely intertwined with business actionability. To meaningfully integrate with the business workflows, it is crucial for model explanations to accommodate the constraints of the broader business. In using the AI lifecycle as a lens, we were able to explore the intersectionality of the social and technical elements of rendering AI models explainable. Our data surfaced a variety of explanation audiences and motivations, including the need to demystify the magic in AI models. This explanatory articulation work is also laden with challenges. The first challenge we observed was about balancing the different levels of AI expertise, both within internal teams and external business stakeholders. Next, there is an inherent simplicity versus complexity trade-off in designing explanations. We also encountered a constant dilemma that our informants face on the sidelines: the concern about explanations revealing identities or too much information about the proprietary AI model. In closing, we'd like to leave you with a quote from one of our informants. "Explainability is like an onion. There's many layers. The algorithms and the data are one layer of that. You want to keep the SMEs or subject matter experts out of the ditches around precision or recall or F1 scores. But you want them to have a higher level understanding of the protocols, the methodology that went into creating this model." We have begun to chart out some emergent considerations for a broadened XAI design space, such as enriching dialectical exchanges between stakeholders by using rich artifacts like model cards, seeking alignment with the model's location in the AI lifecycle, catering to wide variations in stakeholders' AI expertise, minimizing expectation violations during deployment, and balancing technical details with high-level understandings of the AI model. For questions, discussions, or engaging further with our research, you can contact us on the email shown on the slide. And thank you very much for listening.